So now we should have already gone over our equation for linear relationships, so y equals mx plus b, and we're going to move into real world situations. So just remember that m is our rate of change, and it's always going to be multiplied by x, our independent variable. So we're looking for words like multiplied, times, per, each, and then b is our y-intercept. So we're looking for somewhere in our problem where it says adding or subtracting. It may also talk about the original price or the starting point or the initial fee. So let's get started. So this first scenario says an automobile's original value was $22,000. The value of the automobile decreases $1,500 each year. Okay, so I am going to start here with, it says the automobile's original value. So if you think about to what I just said, original value was $22,000. Okay. And then it says the value of the automobile decreases, right? So that goes down $1,500 each year. Each means times, okay? So that tells me that that is my, my number that's going to be multiplied. So I know I'm going to have 1,500x, because it's times year. So x is going to be my number of years. And it says decreases. So if it went up, it would be positive. Decreasing, it's going down. And then we can only have one number that's going to be multiplied, so the other one has to be added or subtracted. And we see original value. So that's my starting point. So the car started out at $22,000 and the value of it went down $1,500 each year. So I'm going to put plus $22,000. Okay, so let's go over and look at our equations just in case we struggled. So since we know each and 1,500 are together, I want my x to be with 1,500. Okay, so this first one I have 2,200 and x. That's not what I wanted. Okay, the second one I have 1,500 and x. That's good. Third one I have 1,500 and x. That's good. And then third one 1,500 and x. Okay, so based on my m, I'm only eliminating one. And it's also decreases. Okay, so I should have 1,500 and x. And it should be decreasing, right? So that's negative. This is positive. That does not look good. This here, 1,500x, well, that's positive too. That does not look right. So now let's go with this one. Is this negative? Yes, because the number, the sign right here before the number, it belongs to the number right after it. So I have minus 1,500x. So don't get fooled just because it's written in a different order. Okay, that's okay as well. So I can just change the order. So 22,000 minus 1,500x. It's the same situation, just written in a different order. You have to just make sure that you keep your signs together. So since this was negative, it can be negative here. Or it could also be plus and negative. All right, so now that we have our equation chosen, we're going to go ahead and fill in our table. So just like we did with our third step yesterday, we did our substitution. So you're going to take your x value, so my first x value is 1, and I'm going to plug it into our equation. So the first one, so I'm going to just go ahead and use the equation they gave us. So 22,000 minus 1,500x. So now I'm going to plug in 1. So 2,200 minus 1,500 times 1. So 2,200 minus 1,500. If I subtract, then that gives me 20,500, right? 20,500. 1,022. So 20,500. So I'm going to plug that in here. Okay, so now now I'm going to move on to the next one, and now I'm going to use 3. So I'm going to plug 3 in. So again, I have 2200, or it's 1000, gosh, why do I keep saying that? Sorry, minus 1500 or 1500 times 3. Okay, so I need to do 1500 times 3. 0, 0, 3 times 5 is 15, 3, 4, 4,500. Okay, so I have 22,000 minus 4,500. Okay, so 22,000 minus 4,500. 0, 0, I'm going to borrow 1, 10, that's a 5. 1, 11 minus 4 is 7 and 1. So we now have 17,500. So 17,500. And I'm going to do my 5th point. Or sorry, my point with an x value of 5. So 22,000, here I go again. Minus 1500, 1500 times 5. So 22,000 minus, do 1500 times 5. 5 times 5 is 25, 5, 6, 7, so 7,500. And now I'm going to subtract. 10 minus 5 is 5. I need to borrow. 11 minus 7 is 4 and 1. So now I have 14,500. All right, so our last step is going to be to graph it. And just to help you guys see better, I'm going to go ahead and use my colors. So first of all, I'm going to go over here. I'm going to use my green, and I'm going to find my y-intercept. So my y-intercept was the value that was added. So that would be my 22,000. Okay, that was my starting point. So I'm going to go up to 22,000, and that is my y-intercept. Because if x is 0, right, the y-intercept is the value of y when x is 0. So that's 22,000. And then I'm going to go to my second point. So this point here, x is 1, y is 20,500. So x is 1, y is 20,500. I'm going to estimate the best I can. Right, and then my next point, x was 3, y was 17,500. So 3, 17,500. Oops. Okay. And then my last point, x was 5. And I had, oh, that point disappeared, sorry, 14,500. So here, let me go back, sorry, do my blue one, it was 3 and it was 17. Okay. So then, once my points are all graphed, then I should be able to connect them with a straight line. Sorry, mine's not perfect. I would use a ruler if I wasn't on my computer. So that is how we solve our first problem. Let's take a look at our second one. All right, so the second problem says that an automobile's original value was 35,000. The value of the automobile decreases 2,000 each year. All right, so we've got this. So we have, I'm going to first start with my each, okay? So I see each here. Oops, sorry, it's hard to read black on here. Okay. So I see each, so I know each means to multiply. So I know that I'm going to have two 2000x, right? Okay, so it says it decreases, so that's going down 2000x, so negative 2000x, right? So I'm going to go ahead and look over here, and I want negative 2000x. So this top one, well, x is with the 35, no. Second one, 2000x, but it's positive, so no. Third one, I have negative 2000x. That looks good. And then the fourth one, I have 2000x. Oh, look at that. We already found our equation based on our rate of change. Then I'm going to keep going, though, and look at the rest of it. It says the original value, right? So the original value is my starting point. So that is my B, my y-intercept. So with that being my intercept, I know I can add 35,000. Okay, so this one, you're going to go ahead and continue just like we did the last one. So we know that if we're adding the 35,000, we said that's our y-intercept. So I can go ahead and plug that in here and graph it. And now you're going to finish by substituting into your equation. So you're going to take your 2 and you're going to plug it in for x, and then you're going to do the same thing with the 4 and graph it. And they're so similar that I know you can do it. Okay, so let's look at number 3. Number 3 says the architect drew a blueprint using a scale in which 1 inch represented 6 feet. Okay, so I'm going to go down, and this time I'm going to use my x and my y to help me. So it's saying x represents the blueprint length in inches. So I know x is the number to be multiplied, right? So I know that I have to multiply x times m. Okay, so I'm looking, it says that x represents the blueprint length in inches. So if I have a scale that 1 inch represents or equals 6 feet, okay, it says y is the actual length in feet. So it's saying y is my length in feet and x is the length in inches, okay? So how do I get from 1 to 6, right? So I need to think about this. I'm going to make a table just to think about it. So if I have 1 inch represents or equals 6 feet, right? So if I have 2 inches, then that would be 12 feet, right? So I multiplied 6 times my x, right? So let me make sure. So going with what I know, if I plugged in my 1 to x, I would do 6 plus 1, and that would get me 7. Well, that's not what I want. And then here I have x minus 6. Well, 1 minus 6 gets me 5. That doesn't give me the length in feet, okay? So these don't look right. Then I have y equals 6x. Well, 1 times 6 is 6. That looks good. And then this one has 6x plus 1. So 1 times 6 is 6 plus 1 is 7. Well, this doesn't say anything about adding. Okay, so my equation is actually y equals 6x. So now what I'm going to do is I'm going to go down here and I'm going to plug them in. So if it has nothing here, it's plus 0. This is going through my origin. Same color, that didn't work out well. All right, then substitute, finish your table and your graph. So we already did 2, so that was 12. Now do the rest.